Hi dear students, so in this section we will discuss the gravitation. So we have already studied that the gravitational force is the weakest force among the fundamental forces. So gravitational force, electrostatic or electric force, and a strong nuclear and as well the weak nuclear and the strong nuclear forces, isn't it? So where the gravitational force is the weakest force, but the range of action of this gravitational force is very high, infinity. The range of action of the gravitational force is very high compared to the other fundamental forces. So before going to the gravitational force and gravitation, we should discuss the planetary motion and Kepler's three laws for the planetary motion. Okay. So in the earlier concept, we were considering that the orbits on which the planets are rotating are in the circular shape. And the sun is situated at the center of the circle. But by doing the further studies, Kepler stated that the orbits are having elliptical shape and the sun is situated at one of the foci of that ellipse. Here the pictorial representation it is given. You can see the planet it is rotating upon a elliptical path and the sun is situated at one of the foci. Ellipses are having two foci. Here in this case, the sun is situated at one of the foci. Other one of the foci should be here. Okay. So the first law of orbits, first law of Kepler's planetary motion, that is the law of orbits, and according to this law, all planets revolve around the sun in elliptical path with the sun situated at one of its focus or foci. Now let us come to the second law of Kepler's planetary motion, that is the law of areas. So law of areas states that the vector joining the sun with the planet sweeps equal area in a particular time interval. Otherwise, we can say equal area in equal time period. So if we are considering here the vector joining sun and the planet will be this one. Okay. So according to the law of areas, or the second law of Kepler's second law of planetary motion, it states that the line or the vector joining the sun and the planet covers or sweeps equal area of equal area for equal interval of time. Okay, so if you are considering a time period at delta t, so for that particular time period, consider the planet is moving and it is moved till here. Okay, for a particular time period delta t. So you can observe now the line which is joining the planet and the sun will be this one. According to the Kepler's law of area, the area swept or area covered by the line which is joining the planet and the sun will be equal if you are considering an other portion at another portion with the same interval of time. Here also another the same planet, consider the same planet is reached here, and this for after a time period of delta t, the same time period it reached at the second point. It was here, after delta t it is reaching here. Okay, so here the area swept by this one also will be equal to the area swept by this portion. The areas will be equal even if the time period is same. That means here we can say the change in area, it is delta A by delta T will be a constant. It means area per unit time will be always a constant. Okay, the area covered by the vector which is joining the sun and the planet will always be a constant for a unit time interval or unit time. Now the third law of planetary motion. Third law is actually the law of time period. The law of time period states that the square of time period of a revolving planet is proportional to the cube of length of semi-major axis. The square of the time period means you can consider the time period as a t. Square of the time period should be proportional to the cube of the semi-major axis. Okay, so t square by a cube will be a constant. So t square will be proportional to a cube. Where this semi-major axis is actually related to the orbital path. Here this is the semi-major axis, this one is the major axis. Okay, a semi-major axis, the length of the semi-major axis is actually a, and t square is the time period square will be proportional to the a cube. Now let us come to the universal law of gravitation, Newton's universal law of gravitation. The Newton's law of gravitation states that all the bodies on the earth are affected by an attractive force by a mass or nearby mass or a nearby body. So due to this gravitation only, even if we are throwing a stone upward, it will come back, isn't it? So the reason behind that one, it is the gravitation. Same way we can walk through the land. We can walk here, we can run here. So that's also due to the gravitational force. If the gravitational force was not there, all the things will float in the atmosphere. The statement of the universal law of gravitation, it is: all massive objects in the universe attracts to each other by a force called gravitational force, whose magnitude is proportional to the product of masses of bodies and inversely proportional to square of distance between them. So here if you can see here, that is F is equal to G into M1 M2 divided by R square. So where M1 and M2 are the various masses. If you want to find out the gravitational force in between two masses M1 and M2, there you have to, if the distance between them it is R, then the equation to find out the gravitational force between these two masses M1 and M2 will be the gravitational force F is equal to G into M1 M2 divided by R square, where G is the gravitational constant. And here you can see F will be proportional to, F is proportional to M1 M2 and inversely proportional to R square. Okay. So we can say the gravitational force is directly proportional to the product of masses and it is inversely proportional to the square of the distance between them. So due to that reason, this gravitational force is also known as the inverse force or we can say this equation, that is F is equal to G into m1 m2 divided by r square, is actually the inverse square law. Okay, the gravitational law can also be named as the inverse square law of d2, that is the force is inversely proportional to the square of the distance between the masses. So here F is the force between two bodies m1 and m2. G is the universal gravitational constant, and its value it is 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. Then m1 is the mass of the object 1, m2 is the mass of the object 2. R square is the distance between m1 and m2 from the center. Okay, if you are having the masses m1 and m2, the distance between the centers m1 m2, from the center to center, you have to consider the distance. Okay, so that is the distance r. And r cap which is representing the distance or the vector or the direction vector for the distance between m1 and m2. So mass m1 and m2, the force acting upon m2 by m1, you can write that one as F2 1. That is the mass force acting upon mass m2 by 1. If you are comparing that with the mass acting upon F1 by 2, the magnitude will be the same. The magnitudes will be equal. And if you are considering the vectors, the direction of the vector will be opposite. So vector F21 will be is equal to minus of vector F1 2. Okay. Now, some of the properties of the gravity. Every object with a mass is attracted by every other object with a mass. That is the gravitational force. All the massive bodies are having an attractive force in between them in the vicinity of the gravitational field. And the gravity is a central force. Central force means the gravity. Suppose if you are considering the planetary system, there is a force between the planets and the sun, and that force is acting towards the sun, into the center. Towards the center the force is acting. So the force direction or the gravitational force direction is towards the center oriented force it is. So that's why it is also known as the central force. And as well, if you are considering two bodies, then from center to center you have to measure the distance. That's also one of the reason for the central, that is the gravitational force is known as the central force. And the gravity varies as the inverse square of the center distance. And gravity directly proportional to the gravitational force is directly proportional to the product of the masses. So this much portion you just go through the textbook and read it. The remaining we will discuss later. Thank you.